Good morning, everybody. We're going to talk about optimization of environmental benign nuclear oil extraction process. First, I'm going to give an outline starting with introduction, objectives, materials, and methods, results, and finally conclusion. So what wheat germ? Wheat germ is a byproduct of wheat milling industry. And this picture shows the wheat kernel structure. The wheat grain consists of starchy film, which is about 80 to 85% of whole wheat grain, and surrounded with a protective layer of bran, which is about 13 to 17% of whole wheat grain. And germ, which is located at the end of the wheat kernel, and represents about 2 to 3% of whole wheat grain. Wheat germ oil contains about 8 to 14% oil and also 26% protein. The percentage of oil present in the wheat germ depends on the degree of contamination with the plant. Wheat germ oil is one of the natural source of vitamin E, and also it contains other bioactive compounds, including polyunsaturated fatty acid, also polyphenol and phytosterol. And wheat germ oil is used in products such as functional foods, nutraceutical, and also in cosmetics formulation. 5 different techniques are used to extract the oil from wheat germ. Solvent extraction, supercritical flow extraction, mechanical pressing, aqueous extraction, and aqueous enzymatic extraction. In solvent extraction, hexane is used as a solvent to wash the oil out of the germ. And this method gives a high oil yield, about 95% or more than 95% of the oil extracted. The main disadvantage of this method is it has environmentally pollutant and also unsafe environment for the workers in the plant. The second method, which is supercritical flood extraction, carbon dioxide is used as above its critical temperature and pressure as a solvent. When the CO2 or the carbon dioxide released from the when the pressure released from the system, the carbon dioxide goes to the gas phases and the oil precipitate out the oil emission. And this method gives the higher oil yield, environmentally friendly, and no solvent residual in the oil. However, the main disadvantage of this method is high capital cost required for the system to be set up. Mechanical pressing is the third method used to extract the oil from wheat germ, and this method is just applies a mechanical pressure to force the oil out of the germ. This method gives an end product free of any dissolved chemical and also considered a safe process and environmentally benign process. The main disadvantage of this method is low oil efficiency. Aqueous extraction. In this method, utilize water or a buffer as a solvent to wash the oil out. And this method is a safe process, environmentally benign, and also simultaneous recovery of oil and protein. The main disadvantage of this method, the low extraction efficiency. The last method, which is aqueous enzymatic extraction. This method is also utilize water or buffer solvent with the aid of enzyme to increase the oil yield. This method is a safe and suitable method. It's environmentally benign also, and some results recovery of oil and protein. The main disadvantage of this method is the enzyme cost. This picture shows the mechanical pressing or the screw press, which is one of the environmentally benign extraction process. As you see, this is the panel or electronic panel, so you can control panel, you can control the whole system. When you prepare the material or the seed is going to be feed in this part, which is the feed hopper. After that, the material is going to be moved using a feed conveyor to the cage section or the barrel. In this section, the seed is going to be expressed and the oil is going to be released from small opening at this part of the screw press of the cage section. So the oil is going to be collected under the cage, and the material which is too large to exit from this small opening at this part of the cage can be exit at the end of the screw press on this part of the press. The last part of this press is called the cone assembly. In this part, we're going to adjust the pressure, the back pressure. So we have which is called the bad pressure plate, so with using the hydraulic pump. So when we push this plate in, we can increase the bad pressure and more oil can be released. Aqueous oil extraction is the second or another environmentally benign extraction process. In this method, we start in the basic stage, starting with the oil-bearing material, grinding to reduce the particle size, and then the drying material we're going to mix with the water or buffer. After that, we're going to intubation using a water bath shaker at specific temperature and shaking speed. After that, we're going to centrifuge it to get the solid phase and the liquid containing the oil containing liquid phase. In this part, we're gonna collect the oil and protein. So this is the the main advantage of this method. We're gonna extract the oil and protein at the same time. After that, we're gonna recover the oil. To the best of our knowledge, no study has been done in the past on the optimization of mechanical extraction. So for this reason, the objective of this study is to optimize the mechanical extraction process to a parameter to increase the wheat germ oil yield without compromising the oil quality. And also to investigate the potential of using two-step processing. Start pre-pressing of the wheat germ by using a screw press, followed by extraction by residual oil from the press cake using another environmentally benign extraction, which is aqueous extraction, to increase the oil materials and methods. Wheat germ was purchased from ADM milling company at the end of Oklahoma, and then the germ was stored in the working cooler under the further use. This is a schematic flow diagram shows the extraction process. I start with the wheat germ, and then I heat it to 180 using double jacket kettle, and after that the heated germ was pressed using a heavy-duty screw press. The preliminary test shows the system of the screw press reached the steady state after 2 hours. That means the crude oil and the amount of crude oil and the cake collected each 30 minutes and the fall after 2 hours is going to be the same or similar. After that, the cake going to be goes to the second extraction step to recover the residual oil in the press cake using an aqueous extraction process. This table shows the level of independent variable used in this study to optimize the system of temperature, pretreatment, shape speed, blood pressure, and shape arrangement, which is different levels of each variable. And a study done by X in 2000 and others in 2009 shows that they work on the aqueous enzymatic extraction, our rule for the wheat germ oil. They reported that the highest oil yield was obtained by non-enzymatic extraction. About 70% of the oil can be recovered at this liquid saturation of 20 and extraction time of about half hour. So I applied this finding to the wheat germ cake after we express the oil from it, so the residual oil left in the breast cake, I use this optimum condition to recover the residual oil in the breast cake in the second extraction process. So results. This table shows the statistical analysis of my data, shows the effect of shift speed, blood pressure, and the cage temperature, and the interaction between them on the oil yield as a shift arrangement and 180 Fahrenheit pretreatment. The result shows that we have the cage temperature, blood pressure, and shift speed interaction is a significant effect, which is p-value is less than 0.05 interaction. So this result shows that the optimum condition after you optimize the system is which gets the highest oil yield about 47.7%, and this is obtained at the following conditions: severe shift arrangement, cage temperature of 225, germ pretreatment at 180, and the high blood pressure with 400 RPM shift speed. So even after you optimize the system, we have just only half of the oil, about 50% of the oil can be extracted using a screw press. For this reason, we are trying to do the second extraction. So because the degree of oil recovery would not be economically visible for the commercial operation. So we have left 50% oil in the breast cake and also high value protein. So we are looking for the second extraction step to recover this two important ingredients in the wheat germ cake. For this reason, we use this table shows the percentage of oil yield obtained from the wheat germ cake as a second extraction using an aqueous extraction and liquid solid ratio of 20 and extraction time at half hour, as I mentioned in the optimal condition from the previous study in our group. So I applied this finding to the breast cake after you extracted the some of this oil. So we have 50% left of oil. So I trying to collect that oil using this optimum condition of aqueous extraction. So the result shows that about 79.6% of the oil can be recovered using an aqueous extraction and boric acid NaOH buffer and using labile grinder. Still, 79.6 is, it's a good oil yield, but still we can improve this by adding some enzyme using an aqueous enzyme extraction, and this is what I'm working on it right now. So I'm trying to increase the oil yield by using some enzyme to see if we can recover more enzyme and protein from the wheat germ cake. This table shows the effect of extraction methods of wheat germ oil on the oil quality. I took the wheat germ oil collected from the supercritical and the optimum condition that I mentioned before, and I compared with the wheat germ from hexane extraction and the wheat germ from the supercritical carbon dioxide extraction. For the free fatty acid, as you see, the wheat germ oil collected from the supercritical has lower free fatty acid compared with the wheat germ extraction from hexane. But still, the wheat germ oil from supercritical extraction has the lowest oil yield compared with the both extraction method. For the BRC value, PMN value, and water content, the wheat germ oil collected from the supercritical optimal condition, it has the lowest value compared with the two extraction method. For the phosphorus content, the wheat germ oil from the supercritical CO2 extraction has the lowest oil yield compared with the wheat germ oil from hexane and the wheat germ oil from the supercritical extraction. In my conclusion, conclude that the highest oil yield was about 47.7 can be obtained at the following condition: severe shift arrangement, GM treatment at 180 Fahrenheit, and also the cage temperature at 225 Fahrenheit, and the high body pressure with the shift speed at 400 RPM. And for the aqueous extraction, we can recover about 80% of the residual oil in the breast cake can be recovered by using an aqueous extraction as the second step to recover the 50% left in the breast cake. So finally, I can say that our new process can be available environmentally benign with alternative to hexane extraction and can be easily incorporated to wheat biorefining system. Thank you very much for listening to my presentation.